Okay, so in review question 14, we're looking at another either gas process problem. So gas begins at a pressure of 4p and a volume v. Assume that for the two processes below, the gas begins in this initial state. An isobaric expansion to a final volume at 3v, and an isothermal expansion to final. So both have the same final volume. So one's an isobaric expansion, one's an isothermal. We define the absolute value of the work done on the gas in process 1 as W1. Which of the following is true? So how does the work done in process 2 compare to 3/4 of the work done in process 1? This might seem like a strange number, but I'll explain the logic in a second. So I'm going to try to draw this without taking up too much room up here. So let's start out trying to draw this process here. So I've got 1, 2, 3, and 4. So they'll represent my pressure. This will be my origin, and then up to V to 3V. So V to alright. So I'll draw this in. So this will represent P, 2P, 3P, 4P. And this will represent V, 2V, 3V. So we're going to start up here at this point at 4PV initial, and undergo an expansion of to 3V. Okay, so this will be our final, this will be our initial, it's an expansion. So let's think about so the work in process 1, think about the area underneath the curve. We know it's an expansive process, so it's going to be negative. It's going to be a negative amount of work during expansion. And we're looking at the area of a rectangle with a height of 4 p's and a base of 3v minus v and a base of 2 v's. So that's the area of this rectangle. So work 1 will be equal to negative 8 pv, or that the magnitude of that work will be 8 pv's. If you think about process 2, it's an isothermal process. So the PV value must always be 4 PV at every point on the isotherm. So I'll add in a couple of data points here. So at 2V, we must be at a pressure of 2P, so we have 2V times 2P. 3 would then be like 1 1/3. So right here. Okay. So that's sort of our isobaric expansion. Sorry, isothermal expansion. Okay. Draw these dot lines here. Okay. And what we're asked to do here is to figure out what is the value, how does this area underneath the isotherm compare to 3/4 of this value. So 3/4 of work 1 would be 3/4 of 8, would be 6 PVs. So there is a way in that we can determine the exact area, but it's not typically covered in our textbook. So I wanted to design a question in which you could sort of use approximations. So what if, let's consider if I was to approximate this particular area as a trapezoid. What would that, which knowing that the area of the trapezoid is, the area underneath the isotherm is definitely less than the area underneath the trapezoid. So let's just figure out what is the area for the trapezoid underneath this purple line. So think about the area of the trapezoid. And I'll do absolute value just to figure out the areas, the exact areas. So we have a trapezoid. I can break this up into a small rectangle and a triangle. Excuse me. The rectangle would have a base of 2v times the height of 1.33 p's. That's where this point, this is 1.33 p. And then we'd have the area of the triangle, and you can use your trapezoid formula if you want. I just wanted to show you where this is, where I'm getting these numbers from. So we're half the base, again half times the 2v times the height. So we've got 2p down to here plus another 2/3. This is 2.6667 p's, and this should give you 5.3 pb's. So that number, so the area underneath the isotherm is definitely less than 5.3, which is definitely also less than 3/4 of 8 or 6 pb's. So the answer is B. The work 2 is definitely less than 0.75, less than 3/4. So I wanted to pick a value that if you were to do an approximation, and just even ballpark figure, the area underneath the isotherm looks roughly about half-ish of the area underneath the isobaric process, so it's likely that it's less than 3/4. So again, even from an eyeball example, you could sort of gauge that this area is definitely, area underneath the isotherm is definitely less than 3/4 the area underneath the isobaric expansion. Now, the equation that's not addressed in our textbook, which you can use, is to define the area underneath an isotherm. So, for isotherms is negative n or t times the ln of Vf over Vi. But our n or t is by definition Pv, and Pv is a constant for an isotherm. So we have negative Pv times the ln of Vf over Vi. So in this example, the work for 2 will be negative 4 PVs times the ln of 3V over V. And you work this out in your calculator, you end up with negative 4.4 PVs. So that's the exact area underneath the isotherm, which of course has to be less than the 5.3 calculated for the area underneath the trapezoid. And as mentioned earlier, it's almost, a little over half of the 8 PVs for work 1. So we can be pretty convinced that the absolute value of work 2 is definitely less than 0.75 of work 1. That's how the question was designed.